Good morning, everyone. I was really happy to see a few of you guys in English from English class yesterday. I miss seeing you guys' faces in the morning. Thankfully, though, we can continue on with the math, and I hope that whatever's going on by you, you are keeping occupied and having still a decent time of things. Well, today what we're going to do is we're going to look at our last concept, and that is, of course, word problems. Now, Monday was our last new idea. Today is our final application. And so what we're going to be doing is we're going to be looking at how you can go about solving word problems and what sort of word problems make systems of equations. And these two questions almost answer themselves or answer each other. The first one is asking, how do I solve a word problem that uses systems of equations? And what you're going to do is you're going to find two variables that are going to lead to two different totals. That's what's going to happen. So that means that you're going to have to identify the at least two variables in play. You're going to have to figure out the totals that you're making with those variables. And notice this is very similar to what we did with our writing word problems or writing equations from word problems earlier. The only difference is this time you're going to write two equations instead of one before you solve. So what sort of word problems will lead to those systems of equations? Well, it's just what it's saying here. It's the sorts of problems that have two variables with two distinct totals. A lot of times I think of these as situations in which you have two situations that you are comparing, or two pieces of information that are different from each other, like different units being compared or combined to get to a final idea. And so let's just jump right into it then. We have this first word problem. In a 1 week, a music store sold 7 violins for a total of $1,600. Two different types of violins were sold. One type cost $200, the other type cost $300. How many of each type of violin did the store sell? Okay, now as soon as I get a word problem, I usually pull out that note card that we made in class. And that note card includes how to find a slope, how to find an intercept, and the various sorts of equations that you can make. Because I know in order to solve this, I'm going to need some form of equation. Now, of course, this one does have smaller numbers, so eventually if you're just plugging things in, you would probably find the correct combination. But if this number was like 400 instead of 7, that combination would take forever, and it might not be possible to solve in the time that you need. So don't try trial and error only for this. Okay, so let's go through this the way I normally would with my note card. I know that I have 7 violins. Not quite sure what I'm going to do with that information yet. I know that it's going to make a total of $1,600. Now, total is great because that means already I've got 1,600 is equal to something, right? It's a combination of a couple numbers. And let's see what other information it gives me. It tells me that two different types of violins were sold, so I've got two situations here. One type costs $200. That means that out of what they're making, I can kind of apply this. They did 200 times however many of these were sold. The other type cost $300. So again, same sort of thing. This is showing me how they ended up with the 1,600. And notice, I know that this is talking about the 1,600s because they're both in the same units. Now, let's add some variables here. Let's call this first type V for violin and the second type T for total, just for fun. And with this one, or T for type, let's do that. With this one, I know that they spent $200 for every V that they sold. So that would be a slope, which is 200 times V, because we're talking about a rate of change here. And in this one, they combined the amount that they got when they multiplied by the first type to the amount of money that they got when they multiplied by the second type. So this is again another rate. I'm saying I'm doing 300 times the number of this type that was sold. So I end up with this formula, and I know they figured out their total cost based, or their total earnings based on these two numbers. The problem is I can't solve this equation because currently I have two variables, which means the best I could do is rewrite it so it's like t equals something times v plus another number. But that doesn't actually tell me how many of each were sold, so there has to be more information. So what I do is I come back and I look at it. Well, I know all of these numbers are accounted for except this number 7. Well, 7 is another total. So if 7 is another total, let's just write 7 equals and figure out what variable combination is there. Well, how'd they figure out this number using only v and t to talk about it? Well, all they said is, we know that they sold 7 violins by taking the amount of the first type they sold plus the amount of the second type they sold. Because if there are 2 of these, well, there'd have to be 5 of these in order to get 7 violins. So that means that 7 has to be equal to v plus t. And that gives us our second formula. Now I'm going to leave this for you to solve because we've done that a couple times we've done that a couple times this unit already, in fact quite a bit. So that's going to be the first thing that you need on your assignment. Let's go on to another example. So you guys are going to find the answer to number 1, check your answer, make sure it works and makes sense. Let's do another one of these. We have the admission fee at a small fair is $1.50 for children and $4 for adults. On a certain day, 2,200 people entered the fair and $5,050 was collected. How many children and how many adults attended? Okay, so I'm going to go through and I'm going to start labeling my variables, figuring out what's going on. First off, I see that they're charging $1.50 for children. So that's $1.50 per children. That makes this a slope. So we're talking here about a slope of m. And our variable for children, let's just call that c. So I know that they're going to take 150 and multiply it by c in order to figure out how much money they got from children's tickets. The next number, 4, is a rate for adults because they're spending $4 per adult or getting $4 per adult. So that means that this again is a slope, and we can give adults a variable of a. So that means that if I wanted to find out the total amount of money that they took in, it would be $1.50 times the number of children plus $4 times the number of adults. And if I look at my remaining numbers, what will this monetary total add up to? Well, it's going to add up to the money option of totals, which is $5,050. However, again, I run into the point where, while I was able to figure out how these numbers combine to get this big money amount, I do not have enough information to solve for A and C at this point. However, I can read back through the problem and see what numbers I may have ignored. And here I can see that they gave me another number, another total of 2,200 people. Now, I don't know if those people are children or adults, but I can assume that were I to add the children and adults, I would end up with 2,200 total. So let's just add C plus A because we know that those are the numbers of children and the numbers of adults that went into the fair. That leaves me with this system of equations, and at this point I'd be able to solve that. Once more, I'm going to leave the solving to you, and make sure that when you write your answer, you tell me not just C equals A equals, but what that means in the context of this problem. All right, we're going to stop there for today, and your only assignment is to complete these 2 problems and be ready for the video lesson tomorrow. So make sure that you've finished the 2 problems from this video and that you upload that on Classroom. I hope you guys have a wonderful day.